Today, we're diving into a hidden challenge in medicine, one that has huge consequences for patient safety. And it's not something you'd find in a medical textbook. Nope, it lives right there in the space between a doctor's eyes and the screen in front of them. It sounds pretty dramatic, right? Could a slightly tilted image really lead to something so catastrophic? Well, the answer isn't about a doctor being careless. It's about the incredible and often totally invisible mental gymnastics a radiologist has to perform every single day. So to really get what's going on here, we first need to understand the fundamental map, the blueprint, that every single doctor uses to navigate the wild complexity of the human body. I want you to imagine a set of invisible lines that just slice right through the body. Now, obviously, these aren't real lines, but they create a shared language, right? A universal grid that lets any doctor anywhere on the planet look at an image and know exactly what they're looking at and from what angle. And it really boils down to three main planes. The sagittal plane, that's your side view, splitting you into left and right. The coronal plane slices you front to back. And the transverse plane, that's a cross-section, looking from the top down or bottom up. These are the absolute fundamentals, the north, south, east, and west of human anatomy. All right, so we've got the map. Now let's talk about the expert who has to read that map, often at lightning speed, the radiologist. And more importantly, let's talk about the one resource they have that's not infinite, their own brain power. You know, every single task you do, I don't care if it's making a cup of coffee or performing brain surgery, it places a demand on your working memory. That mental effort, that strain, is what researchers call cognitive load. The best way to think about it is like your computer's RAM. You know how when you open way too many programs at once, everything starts to slow down, it gets laggy, and eventually it might just freeze up and crash? Well, the exact same thing happens to our brains when we push them past their limits. That's cognitive overload. So this cognitive load thing, it basically comes in three flavors. First up is intrinsic load. This is just how hard the task is, period. And let's be real, finding a tiny life-threatening abnormality on a messy CT scan, that's an incredibly difficult job. That high level of difficulty is baked right in. Then you have what's called germane load. And this is the good kind of mental effort. This is the energy a radiologist uses to connect the dots, to see a faint shadow and have it trigger all their years of training and experience about what that could be. This is the load that actually makes them a better doctor. And that brings us to the villain of our story, extraneous load. This is the mental energy that is completely wasted on pointless garbage. It's the cognitive price you pay for poorly designed systems or confusing information. And that mental effort it takes to mentally rotate a tilted image just to figure out which way is up, that, my friends, is 100% pure, useless extraneous load. So what happens when you smash these two ideas together? You've got this universal map of the body on one hand, and this concept of unnecessary, brain-draining extraneous load on the other. This is really the heart of the matter. When a CT scan is shown in that standard, agreed-upon orientation, the extraneous load is super low. The radiologist's brain can just get to work on the hard part, the important part, making the diagnosis. But when that same exact image is tilted or off-kilter, it's like handing a pilot an upside-down map during an emergency. Their brain is forced to do all this extra work, mentally rotating every single slice before they can even start their real job. It's just wasted cognitive fuel. And look, this isn't just my opinion. This quote comes directly from the researchers who study this stuff. And a medical image that isn't oriented correctly is a textbook, and I mean a potentially dangerous example of suboptimal presentation of task information. And we have to be clear, this isn't just a small annoyance or some academic theory. Wasting a highly trained expert's limited brain power on these kinds of mental gymnastics has profound, real-world consequences for real patients. And get this, the research is startlingly clear. Most diagnostic errors in this field don't happen because the doctor doesn't know enough. They happen because of failures in perception. The doctor just doesn't see the problem. And that useless extraneous load, it is a massive contributor to these perceptual blind spots. And this is where things can get really serious. When one of those perceptual errors, fueled by cognitive overload, leads to a misdiagnosis that harms a patient, well, that's how a simple design flaw, like presenting an image the wrong way, can spiral into a personal and legal disaster. So what's the solution? Is it just telling these incredibly smart, highly trained experts to try harder or pay more attention? No, absolutely not. The real solution lies in designing better systems that actually support their expertise instead of sabotaging it. We have to shift our focus away from just blaming individuals and start looking at the systems they're forced to work in. The goal has to be to ruthlessly hunt down and eliminate every last bit of that extraneous cognitive load, so that radiologists can dedicate all their mental firepower to the thing that actually saves lives, the diagnosis. And here's the fascinating part. This is actually how experts already work. As they gain experience, they naturally develop these incredible mental shortcuts to manage the load. They filter out junk data, they check old scans, they rely on pattern recognition. Our technology should be designed to help them do this, not get in their way. And the easiest, most powerful strategy of all, just show them the image the right way up, every single time. Standardization.